Okay, so we get started. 2F today we're doing derivatives of exponential functions. So what's an exponential function? It's when we have some number to the power of x, right? And in 99% of cases, we're going to be 99% of cases, we're going to be looking at e to the x, but we will look at other numbers as well, which pop up later in the exercise. So let's just start with e to the x because that's the most prevalent form of derivatives of exponentials that we do. So if we have y is e to the x, the derivative is e to the x. This is the only function for which it's true for. When you differentiate it, you get the same function. Hence the meme on the front page, okay, about the cat hitting the thing. Doesn't make a difference no matter how many times you differentiate it. If we have e to the power of f of x, all right, the derivative is whatever that is when you differentiate it, that becomes a multiple out the front, e to the f of x. So that part stays the same. All you're doing is differentiating the power and putting it at the front as a product. So let's get straight into it. We have 3e to the 2x plus 5. We have 3e to the power of f of x. It's some function here, right? So when we differentiate it, we're going to do this in one step. So I'm going from y to dy and dx. The 3 is just going to hang out. The 3 is multiplying its product, so it's just going to stay there. And then we've got e to the f of x. So we need to go, what's the derivative of 2x plus 5? 2. It's going to be 2, all right? So that's that part there. The 2 is that part there. And then we just have e to the 2x plus 5. Okay? Full marks there, all right? And if you jumped straight to here, as people tend to do as well, because they can do 3 times 2 in their head, that would also be correct. They mean the same thing, all right? So what do we do there? We've got e to the f of x to differentiate it, f dash of x, e to the f of x, and the 3 just hanging out. On to the next one. We've got y equals x squared times e to the x. X squared times e to the x. How do we differentiate this? What's the rule we need to use when we've got two things multiplying? Product rule, very good. Product rule, we have one function multiplied by another. Okay, so we're going to pick up product rule and quotient rule a fair bit now that we have derivatives of exponentials. So we're going to have u is x squared and v is e to the x. That means our u dash will be 2x. And our v dash, what's the derivative of e to the x? E to the x, okay? And then we've stated our u's and v's. We're ready to make a statement about dy and dx. Smash it all together. U dash v plus uv dash. All right, so that's how we should express it. Now, there will pop up problems like this where it wants you to find the roots of it and so forth. So I just want to show you how we can manipulate this a little bit further. We can look along and we can factorize it. All right, we can see that e to the x and e to the x is common to both terms, so we can pull that out the front. But x is common to both as well. So we could factorize it to look like this, couldn't we? All right, this and this are the same. Just different ways of representing it. And then here, if you're finding the roots, you can go on and apply the null factor law, right? So that's how we would find roots there. But different ways of representing it. For differential calculus, you get full marks there. Okay, last one. And this one's going to be a big mess. All right, I'll just tell you. All we're doing is following the rules. Okay, all we're doing is following the rules. And that's all maths is. Like right here, the answer's here. All you're doing is performing an algorithm and just manipulating this and arriving at something different, all right? The answer's here, we just need to differentiate our way to it. So we have one function divided by another, okay? Very clear because it's represented as a fraction. What rule do we use when we have one function divided by another? Quotient rule, all right? So u is always the top of the function, and we should always express it in a form that's ready for us to differentiate. All right, so square root of x isn't particularly useful, but when we write it as x to the half, that's a form that we can differentiate. Similarly with v at the bottom, I'm going to jump straight to it expressed as a power. X, take 3 e to the x to the power of a half. All right, so you can see how these rules just sort of compound. So now when I do u dash, all right, we've got the power rule here. Derivative of 3x to the 4, that's going to be 12x to the 3. Take away. All right, so here's where the new part's coming in, where we're learning something new. We've got e to the power of x to the half. It's e to the power of a function. All right, so the derivative is f dash of x, e to the f of x. So we need to say, what's the derivative of x to the half? Half x to the minus half. Okay, that's that part. And then we need to e to the x to the half, e to the f of x. F dash of x, e to the f of x. Okay, so we've got quotient rule, we've got power rule, we've got derivatives of exponentials. Okay, we've used 3 rules so far. Over here, we've got a function to the power of n. What's the rule we use there? Chain rule. Okay, so now we've added in a 4th rule. You can see how you look. This question is a great question because it's testing you on all those things. So if we have a function to the power of n, the derivative is n f of x to the n take 1. Okay, n f of x, n take 1, multiplied by, and then the derivative of the inside. So if I'm differentiating what's inside the brackets here, derivative of x is 1, derivative 3 is just going to hang out because it's a product, and derivative of e to the x is just e to the x. All right, so you get there, you know, you've got 2 out of 3 marks so far. All right, from doing the u dash, v dash. And so let's smash it all together. U dash v. Oof. U dash and then v. And so when there's heaps of stuff going on like that, it's really easy to put a half in the wrong spot or forget the brackets or something like that. All right, remember, u dash in brackets, v in brackets. Take away u, 3x to the 4, take e to the x to the half, u, and then v dash. Let's smash that there. All right, so in that step, you don't want to make any mistakes. All you're doing is copying what you've got up here, but make sure you're putting it in the right order. U dash v, take away, u v dash. All right, and I've seen students just stop there. That's a mistake. It's all on top of v squared. All right, and so I can just jump straight to there, 3e to the x. All right, when you square that, it just gets rid of the root. All right, so we can see, what did we have there? We had power rule, we had derivatives of exponentials, we had chain rule, we had the quotient rule, all combined in one question. It's about doing them in the right order. We recognise quotient rule, that's the rule I'm using here. So we set out u dash, v dash. We write u, we write v. Differentiate u, we've got the power rule, exponentials. Differentiate v, we need to use the chain rule. We've got a function to the power of n. So there we go. They will start pretty easy. They will start like this just to familiarise yourself with the techniques, but then they will develop into some more complex ones as well. Splendid. Let's get started on 2F.